Welcome to the session 1 of computer graphics and its visualization. So in this session we are going to discuss on the attributes with respect to point, with respect to line and the curve, and the OpenGL function with respect to the point attributes and the line attributes. Now, before we go into discuss about these attributes, and these are the OpenGL functions to draw a point or to draw the different types of lines using GL lines, GL line strip, GL line loop. And to draw the point, you're going to use GL point. Static character is going to replace with the three characters what have been mentioned. So if you're going to have two dimensions, it's going to be 2, and for three dimensions, it's going to be 3. If you're passing an integer value or a floating point, depending upon what type of value you're going to pass or parameters, we are going to replace the respective GL vertex function over here. And we are going to enclose this vertex function between these two APIs, GL begin and GL end, where this GL begin is going to take a parameter, so either GL points or GL lines, GL line strip and GL line loop. So depending upon what type of primitive you require, you're going to pass that primitive as the parameter for the GL begin. So now just look at this code here. We are going to have GL begin and GL end. As I told you, the GL vertex function should be enclosed between these two, and we are going to have GL vertex function. The asterisk has been replaced with 2f, so which says I'm going to have a two-dimensional point and floating point values, the parameter what I am passing over here, and even the primitive what I am passing for GL begin is going to be GL points. And so once I put this content and this set of APIs, when I execute, now this is the output what I'm going to get. The 5 points which I mentioned using GL vertex 5 times. Each vertex is for each point. Now this is the output what I'm going to get. I'm going to get 5 different points. The first GL vertex is this point. Hence we can say as P1, P2, P3, P4, P5. Hence we are going to have 5 vertex functions here. I'm using GL points here, and so I'm going to have 5 points as an output. Fine. So now next we will just discuss about this GL begin. So where again we are going to just replace this GL point with GL lines. So now for the same 5 points, if I'm going to have GL lines, this is the output what I'm going to get. And so the output is going to be like, I'm going to have the first line which is going to be drawn between the first two vertex, and the second line is between the point 3 and the point 4. And to draw the next line or the line number 3, there is no sixth point, and there's only 5 points. Hence, it if there was the sixth point, I was using 5 and 6, and I would have been drawn the next line. But there is no such points. Hence, so this is going to be just drawn as a point, or this will be ignored even to draw. And this is how the GL lines is going to behave. Now, if I replace this GL line with GL line strip, the same 5 points, now look at the difference of what I'm going to get. So I'm going to have 4 segments, 4 line segments. That is, with the 5 points, now I'm going to draw 4 line segments. The first line between the first 2 points, the second line between the second and the third point, and the third line between the third and the fourth, and the fourth between the fourth and the fifth. This is what happens when I'm using GL line strip. So now if I'm going to use GL line loop, so now for the same 5 points, this is what I'm going to get. It is exactly the same as GL line strip, with one difference is that we are going to have fifth line segment which will be drawn between the last point in your GL begin end along with the first point. Hence we are just going to have a one more line segment between the last point and the first point. Now this is how the GL points, GL line strip and GL line loop will be used whenever you want to pass it as a primitive. And so this was just a recap. So just a recap session where you are going to understand how exactly we are going to make use of this primitive. If you are clear enough, so we'll discuss about the attributes, the point, the line, the curve, and its respective OpenGL functions for the point attribute, the line attribute. So hence, when I discuss about the point attribute and its respective OpenGL functions, so now for every point, there's going to be these two attributes. There's going to be a size attribute for a point, and there's going to be a color attribute for a point. When I say a size, now this is going to be a default point, which is going to be of size 1, and I can increase the size by 2. I can increase the size further with any number, and I can increase the size, and this is going to be different size of a point. And along with this, whenever you're going to have the size, as I told you, so this is the attribute, and we are going to have OpenGL function to set the size of a point. Hence, we are going to use the GL point size. We're going to use the GL point size for that. So where this GL point size by default, if I don't use GL point size, by default, it's going to have the size as 1. That is exactly 1 pixel on your display device. It's going to be 1 pixel always on your display device. Hence, we are going to have it as default. If you don't use GL point size, your OpenGL will use 1 pixel as a default size. And if you are trying to increase the size, it's going to be always a square block of pixel. Now what is square block of pixel? Just look at this. Now this is a point which I am drawing by just using only 1 pixel. That is, the square block of pixel is one side, that is 1 cross 1 is the block. And if I am going to increase the size by 1, we are going to have a 3 cross 3 square block of pixels. And further, if I increase, we are going to have 5 cross 5 square block of pixels. And this is what we call this as square blocks. Now, whenever we are going to mention the size, every time we are not just increasing the number of pixels, as size 1 is 1 pixel, size 2 is 2 pixels, size 3 is 3 pixels. That's not the case. Just observe. For size 1, it's 1 pixel. For size 2, it's going to make use of 9 pixels. For size 3, it's going to be 25 pixels. That is what we are going to increase the size along with the size of the square block of pixels. Now, this GL point size returns nothing, hence it's void, and takes a parameter as a size, and it's going to be integer value. Even if you are passing a floating point value, it is not going to throw a compile time error, but rather it is going to round off. It is going to round off to its nearest value, and it is going to use that size. If I want this, I'm going to pass it as 1. If I'm going to have this as the size of the point, I'm going to pass it as 2. If I want this as the size of a 1 point, I'm going to pass the value as 3. Now this is an example of exactly this GL point size should be used. Hence, I'm going to have GL point size, I'm giving 2.0, and GL point size 3.0. Hence, I am giving different size for different point. Hence, I can use this GL point size outside the GL begin or inside the GL begin, but make sure it's going to be in these two places. If you put it outside or after the GL end, its effect will not be shown on this particular point what you're going to draw. Hence, you can put the GL point size either inside this block or before this block is going to start. And this is going to be the point attribute with respect to size. Now we'll just look at the point attribute for the color. So now I'm just going to have a point. Now this point has been drawn using the color blue. Now I just want this point color to be drawn in red. So hence for that case, we are just going to use a function which is going to be GL color 3F. We're going to use the GL color 3F function whenever we want to change the color of a point or an attribute of a point. And so now we are going to have GL color 3F, so which is going to make use of RGB color model. It's going to make use of RGB color model, so which is going to be the mixture of intensity of this RGB. Hence, we are going to use the function GL color 3F, which is going to take three parameters. The three parameters for the three component of your RGB color model is the red, green, and the blue. Hence, we are going to have float R for red, green, and blue. It's going to be a floating point values. Any value between 0 to 1, or even if you give more than 1, it's going to approximately adjust its intensity to mix the color. And for example, I had wanted the point color value to be red, hence we are going to use GL color 3F. The red component is going to be complete 1 or 100 intensity. The green is going to be 0 intensity. The blue is going to be 0 intensity. So if I execute this color function before I'm going to draw a point either inside the GL begin or outside the GL begin, I'm going to change the attribute of a point color from blue to red. Now this is going to be the point attribute size and the color, and its respect to OpenGL function, GL point size and GL color. Similarly, we will look at the line attribute and its OpenGL functions. So now, similar to point, we are going to have the attributes for the line, so which is going to be the width, style, and the color. Now, when I again talk about the color, it is almost the same OpenGL function what I have been used with the point, the same OpenGL function I'm going to use this with the line attribute also. Hence, though the line attribute has got these three attributes and the point had got only two attributes, now the color attribute is similar to the way I have discussed with the point. Hence, so let us not discuss much about the color attribute with respect to line. Hence, we'll concentrate on discussing about the width attribute of a line and the style attribute of a line. So now we are going to draw a line something like this. Fine. When I draw this line, now this is the default width of a line, so which is going to use 1 pixel whenever we are going to draw the line for every move what I'm going to make in x-axis or y-axis. Hence, by default, it's going to use 1 pixel whenever it's going to draw the line in every segment. So now, if I want to increase the width, the one technique is I'm going to draw one more line, a parallel line, so which is going to be along with this line. So that is, we are going to have a parallel line, so which is going to be with this line, which will make the line to look like thicker line, or which is going to increase its thickness. Hence, we are going to have one technique to increase the width is we are going to draw a parallel line exactly moving 1 pixel down or moving 1 pixel up, either in x-axis or with respect to y-axis, which depends upon which axis span you are going to use. If I talk about a style, the attribute style with respect to line, now whatever with the line by default we discussed, so this was a solid line. We are going to have a dashed line and we are going to have a dotted line. When I talk about a style, so three different types of style what we can produce as part of line attribute. And so now to produce this, we are going to modify a line drawing algorithm to generate such lines, either to increase the width or to have any type of style of line. We are going to generate such lines by modifying the existing line drawing algorithm. For example, whatever the business line drawing algorithm we have been using, So we are going to use the same algorithm with slight modification. So we are going to have this different types of lines, and either we can use some custom document brochure. This is going to be a package. If your OpenGL has been configured with this package, or if it has been installed with this package, you can make use of this. If there's no such package, so either we need to modify the existing line long algorithm, or there are few limited number of OpenGL functions which will help you out in handling the width of a line or handling style of a line. Now we'll just look at how to handle the width. Later we'll just look into the style. Fine. So now, whenever going to talk about the width, its respective OpenGL function is GL line width. So now, using this GL line width, we can modify the width or increase the thickness or decrease the thickness. Hence, we are going to have the function. So which is going to be of the data type is going to be void, and the parameter is going to be a width. Again, it's going to be an integer value, or even you can pass a floating point number. It will be rounded off to its nearest value. So as I mentioned, the parameter width can be an int or a float, and the default width is 1. That is, if you don't use GL line width, by default it's going to be always the size or the width is going to be 1. So pixel spans for thickness or width. That is, this is what I mentioned. Either we are going to draw a parallel line by increasing the number of pixels exactly by 1 with respect to y-axis or x-axis. That is what we call this as spans. So now we are going to either choose the vertical pixel spans or horizontal pixel spans. That is, if we are going to use the pixel spans with respect to x-axis, we are going to say it as horizontal pixel spans, and if we are doing with the y-axis, we're going to call this as vertical pixel span. So now if you are wondering, so what is pixel spans and what is y-axis and x-axis and what exactly all this is going to be, now just look at this figure now. Fine, and look at this line. Whatever the black solid blocks have been arranged here, this is going to be the actual line what I have been drawn. And now whatever the grade blocks have been used along with this line, this is the increase in the thickness. I'm increasing the thickness. By default it was 1. Now I'm increasing the thickness by 1. That is, total width of this line is going to be 2 now. Hence, right now if you just observe, now this is x-axis which has been used to draw the line, and just observe where the thickness has been increased. The thickness has been increased with respect to y-axis. I have increased with respect to y-axis, again this y-axis, 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 until the last point what I am going to draw of the line, we are going to increase with respect to y-axis. The thickness has been increased with respect to y-axis. This is what we call this as pixel spans. All these are pixel spans. So right now it's going to be with the y-axis. Hence we are going to call this as vertical pixel spans. Now if you observe this line, the second line, so now I'm going to have this as a line, and now I'm increasing the thickness of this. Now if you just observe, the thickness has been increased or added the pixel to increase the thickness with respect to x-axis, and this is what exactly I mean by horizontal pixel spans. Hence I'm increasing the thickness with respect to y-axis, I'm increasing the thickness with respect to x-axis. Hence, now when should I use this? When should I use vertical pixel spans, or when I should use the horizontal pixel span? It depends upon the difference between dx and dy. That is the two endpoints and the difference. That is what the slope is going to do, and the difference between these two will tell me which exact pixel spans we are supposed to make use of. Fine. So with this, we are going to have GL line width. And this is an example for GL line width. So now we are going to have GL line width API. I'm just passing the value as 5, and the line whatever I'm going to draw now is going to be of the line width 5, something like this. And if I change the width, GL line width 10, I'm going to have the line width is going to be increased by 10. So now if you just observe, in this both the cases we are going to use the horizontal pixel spans. Now this is going to be all about your line and the width attribute. Now we'll just check out. Now in this line style attribute, as I mentioned, these are three different styles what we can produce, and its respective OpenGL function what we are going to use to work with the style of the line is going to be GL line stepple. We're going to use this API to draw the different types of line. And this GL line stepple takes two types of parameters. The first one is the repeat factor, and the second one is the pattern. Now, if you just observe the repeat factor and the pattern, the parameter. Now, this is going to tell me, the pattern is going to tell me what type of line I'm going to use, right? So if we are going to fill the entire pattern, the entire pattern is on, we're going to get a solid line. If you make the pattern to be on off, depending upon what type of pattern you require, I'm going to get a dashed line. So the frequency of on and off you're going to use will decide whether you're going to have a dashed line or you're going to have a point line. And the repeat factor is, I've set a pattern. Now how many times this pattern should be repeated before I'm going to draw the next time of pattern. Hence, now every pattern, what I told you, the pattern should be set. Hence, we are going to have 16-bit integer which is going to describe the line style. That is what the pattern is going to be of 16-bit. Now just observe over here. Now I'm going to have 16 bits here. So now this pattern is going to always work with 16-bit integer, hence I'm going to use 16 bits here. This is the lowest bit and this is the highest bit. And so now I can mention this value in the form of hexadecimal, or I can mention this parameter using a decimal value or integer value. Now when I say FFF, I am using every bit is going to set to be 1. If it is 1, we say the pixel is on. If it is 0, we're going to say the pixel is off. But now just observe, every bit is going to be 1, hence every pixel is going to be on. So this is what every bit is going to be on now. Hence we are going to get a solid line in this case because there is no off bit in this entire pattern. If we just look at this second pattern where we're going to have 00FF in hexadecimal, or its equivalent 255 in a decimal or integer value. Now just observe here, all these 8 bits are 0 and all these 8 bits are 1. And so these are all on bits, these are all off bits. This is on bits, hence I am going to write a pixel over here, and it's off bits, hence we are going to not draw, or we are not going to put anything in this pixels. And if you just observe one more example, FF0, it's similar to this. The equivalent decimal value is 65283. These are all on bits and these are all off bits. And one more example, if I mention CCAA, which is 52394, now this 11, hence it's on. It's 00, it's off. 11, on, and off, on, off, and so on. This is the pattern what I have been set. Now whenever I'm going to draw the line, first I'm going to set this pattern. Later on I will tell you what is the repeat factor. When I give it as repeat factor, if I say it as 1, this pattern will be used every time. In every cycle is going to use only once. If I use 2, so this pattern will be used twice every time. Hence, we're going to have a 16-bit integer to describe the line style. So now this is the pattern what I am going to give decides what type of line we are going to draw, and the pattern will always start from the lower bits. Hence, if I'm using this as the pattern value, then first we're going to draw a solid, then we are going to off it. We are going to write the pixels, we are going to off the pixel, and the line continues with again drawing and offing, drawing and offing, and so on. And if I use this, the lower bit is off, hence I am not going to draw any pixel, then I'll start to draw the pixel. I'm not going to draw, then I'm going to start. That is what the starting with the lower order bit is going to be. And the repeat of the pattern is going to be depend upon repeat factor. If I give it as 1, the pattern will be keep on repeating continuously, and if I give 2, the same pattern is repeated twice every time. And so if it is a polyline, in the case of GL line strip or GL line loop, in the case of polyline, the pattern will continue. The pattern will continue. It is not going to break the pattern or flow of the pattern between the two line segments. If it is not a polyline, then there is going to be a break in the line segments. But in this case, the line segment is going to have the continuous application of this pattern with the poly. Is going to be all about the line stipple function, which is going to draw these functions or draw these different types of lines. Now just look at this program example. Fine. And now whenever I want to make use of GL line stipple, you need to remember that you need to enable it first. If you don't enable, so this API will not have any effect of its on your GL line stipple. Fine. Uh, so now this GL line enable should enable the GL line stipple. Remember this. So hoping that we have done this, we'll just look at the code segment. Now in this code segment, I have been set the line width to 5. Along with this, I am going to use the GL line stipple to have the different types of line. Now I am passing it as 1. That is, the repeat factor is 1. Hence the pattern should be keep on repeating only once. It should repeat, but only once the pattern should be used in every loop. And now I'm going to use F. That means, so this should draw a solid line for me. Hence, we are going to have this as an output. Now, if I just change this value, as 255, as per this example, this is the output what I'm going to get. I'm going to on, then I'm going to have off state. I'm going to have on, I'm going to have off state. Hence, this is the repeat 1, this is the repeat 2, repeat 3, and so on. Now we are going to have GL line stipple. The function I'm passing a different value over here as ff00, as in this case I'm going to have the same output, but if you just observe, now I'm going to start with off state, then I'm going to have on state. And if I'm going to pass the value as CCAA, now this is the pattern what I'm going to end with. So this is the pattern what I've set. So in the repeat case, this is going to be the entire line with the line segment what I'm going to have. And as I told you, we can pass hexadecimal as a parameter, or we can pass the decimal as a parameter of its equivalent. Hence, instead of having CCAA, I would have passed this as 52394. Fine. Now this is going to be about the line style and the line style OpenGL function, and what you're supposed to do before you're going to make use of line stipple function in your OpenGL program. Fine. So now we will just look at other functions, but before you're going to end this program, so make sure you're going to disable. If you want to disable the line style, we're going to use GL disable and GL line stipple. So these are the different types of attributes what we have discussed. So with respect to this primitive, we have discussed this set of attributes. For the point, we have discussed the color and the size. For the line, we have discussed color, width and the style and its respective APIs. The GL color for the color attribute, GL point size for the size attribute, GL line width for the width attribute and GL line stipple for the style attribute of a line. And so this GL enable and disable, which we are supposed to use whenever we are going to enable the GL line staple or the GL style in your program, or whenever you want to disable this. So now with this type of attributes, now we will just have a quick glance of exactly what the curve and its attributes are going to be. The curve attribute is similar to the line attribute as the color, width and the style. So whatever the discussion we have made with respect to line, everything we can apply to the curve attribute and the curve style also. Hence we call this as it is similar to those of line drawing of a curve. And this OpenGL, so remember, frankly speaking, the OpenGL does not consider the curve to be a basic drawing primitive or the primitive at all, because whenever we are going to draw a curve, it is going to be always an approximated shape or the shape approximation which we are going to do using set of short line segments. Hence usually the OpenGL is not going to consider it as the basic drawing primitive. Hence you don't find the OpenGL functions for the curve which is going to be used directly. Hence we need to use some libraries or use some auxiliary libraries, something like we are going to use SP lines. Now this is going to help me out in drawing a curve using the library utilities, or we are going to use an auxiliary library utilities called as OpenGL evaluator functions. Now when I want to make use of curve, so the few things which we need to keep in mind. So hence there is no any direct OpenGL function which is going to help us in drawing the curve. This is going to be all about the curve and its attributes. So thank you for this session.